Hello everyone, welcome back to another tutorial on LlamaIndex. Recently, LlamaIndex has released 0.9 version and there are really some interesting updates. And today, in this video, we'll go through each of these updates in detail by walking through the notebook. So let's get started with it. On a higher level, it has 5 important updates. There are many few other updates as well along these 5 updates. But in this video and in this notebook, I'll be concentrating mostly on these 5 updates and how can you use these things in your RAG pipeline and make it much more efficient. So to start with, we have ingestion pipeline, which will help you to easily ingest the data, and then transformation catching, either in memory or is Redis cache, and then custom transformations. While creating an ingestion pipeline, you may write your own custom transformations and include them in the ingestion pipeline. And the fourth one is enter new. We have a new interface for node parsing or text splitting. Partially, we will cover this in the ingestion pipeline as well already, but we'll show it as a separate thing. How can you use it? And the fifth one, tokenization and token counting. Token counting is one of the important aspect in building a RAG pipeline because it will help you to estimate the cost of your RAG queries or the entire pipeline. So we have an update on that end as well. So let's go through each of these and then see how they'll make your RAG pipeline much more efficient and then easy. So we'll start with, I have already installed the necessary libraries, LlamaIndex, Redis, and Quadrant Client. We'll use Quadrant Client to show you how can you build a transformation catching with Redis using Quadrant Client. So let's have the OpenAI key. Let's fix that. So don't worry, after this video, the OpenAI key will be deleted automatically and you can't use the same key. And then we'll use the usual Polygram SAText dataset for this tutorial. And then I'm downloading the specific data for the same. And then we'll load the downloaded data. Now, whenever the data is being in a RAG pipeline, you do some transformations, right? So the one is the text splitter, and then the node parser, and then probably you can add metadata, and as well as you can even use a different embedding model. And so once you have data, you do all these different kind of transformations and then create nodes out of it. And once the nodes are created, we'll build an index and then we'll be able to query using this index, either an in-memory index or you want to store the same things on a vector DB, that is also possible. So this ingestion pipeline will ease the process of creating nodes and so whatever transformations you want to use for creating those nodes, it's very simple by using an ingestion pipeline. So let's start with a simple one, a sentence splitter. So as a transformation on the given data, so we'll fix the chunk size as 1024 and chunk overlap of 100. And then we have a transformation here. So we will create an ingestion pipeline, which is a pipeline object. And then we'll create nodes. All you need to do is pipeline.run, where documents is your whatever data we have loaded till now. So which will create the nodes accordingly. So yeah, this has created the nodes with, I'm showing here the first node, and then there is text for the same of the first node. And there are a lot of other metadata and other information as well. So this made it very simple in creating the nodes with, here we have seen with sentence splitter. And then you want to add the metadata. So we have a lot of different metadata extractors as well, like title extractor, summary extractor, and question extractors as well. So let's use this title extractor here. So here we have a transformation of sentence splitter earlier. Now we are adding a title splitter, title extractor here. So keep them in the transformations, create a pipeline, and then run the pipeline to get the nodes now. So the titles are getting generated, and then you can check the title for it. So it has the title extractor as is one of the metadata extractor. So you can check in any of the nodes, and as you can see, the title extractor title is same across all the nodes, right? So this way you can have include different transformations from text splitter to metadata extractor, and then even you can even include embeddings. Here I have included a OpenAI embeddings, but you can there are a couple of other embedding modules in LlamaIndex, and you can include them as well. So here we have sentence splitter and then title extractor, and then OpenAI embeddings as well. So we have created the pipeline, and let's create the nodes. So this should now contain metadata as well as the embeddings as well, and as well as the usual however you created the sentence splitter earlier as well. So all these transformations should be present now. So let's check with it. So yeah, it has embedding, the OpenAI embeddings, and then yeah, the usual text is here, right? And then let's check the metadata. I think it should be in, yes, this is here, the document title. So document title, as you can see, the meta title extracted has been changed because we are sending the text to LLM again to extract the title. So the title will be changed, which is different from the earlier one, right? So yeah, and then we have we can create an index. So now the nodes are created, we can create an index and create an query engine accordingly with similarity top k equal 4, and we can start querying the index in a similar manner. So yeah, what did Polygram do growing up? And we have an answer. Polygram worked on writing and programming during his upbringing, and various other things. So this is how you can easily create an ingestion pipeline, whatever transformations you want to make on the data you loaded or the data set you want to use, and create nodes and use those nodes for your building an index and building a query engine and start querying on the index of the query engine. So this will make your process easy and build a production ready pipeline very fastly. And then there is async version of ingestion pipeline as well. So you can check out in this link that I have attached in this notebook. So the next one which we cover is transformation caching. So till now we have created an ingestion pipeline involving a text splitter and then a metadata extraction and also including embeddings. And you build an index and do some build a RAG pipeline and do some evaluation as well on how you were indexing actually how your entire RAG pipeline is good with some defined metrics. But then again, let's say I want to test out different, let's say, different extractors or maybe different embeddings as well. Okay, I don't have to really, let's say I want to have different metadata extractors. I don't have to run the sentence splitter again and again, right? It unnecessarily takes more time. And also, let's say the text splitter and the metadata extractors are fixed, only the embeddings are changed. So in that case, I don't have to even create the create metadata each time, right? You just change once you have the text splitter and the metadata extractors created, like title extractor or summary extractor created. Okay, now you can just load the same, use the same created nodes, or maybe the text splitter and then metadata. And on top of that, keep on changing the embeddings. That's it, right? You just need to load the same thing and apply new embeddings and do the same apply the embeddings on the same data or the same nodes, right? So for in those cases, transformation catching is very helpful. This really accelerates repeated executions, and also will make your iterations very faster. So let's see how can you do transformation catching here. So um, so we have created a pipeline here, and then which has text splitter and then title extractor, and then we'll save it and load the same pipeline again. So we have saved it with llama cache.json and yeah, new cache.json. So and then we have loaded the whatever cached transformations. Now we define the same things, but we mentioned that there is cache here, and then we'll define the new pipeline. And now we can run the new pipeline. See here. So if you see, it has taken 5.1 seconds earlier without cache. Now it took just 0.5 seconds. It just loaded. It just took 0.2 seconds to create the nodes, because we have cached the earlier transformations. So it just loaded. But let's say we want to add embeddings, OpenAI embeddings, and then we use same title extractor and sentence splitter. Now you can just run it by adding OpenAI embeddings. So see here, it just took 2.4 seconds because it already loaded the title extractor and sentence splitter which I have created earlier from the cache, and applied the OpenAI embedding transformation. So it might have taken probably 5.1 seconds plus 2.4 seconds more, plus 7-8 seconds. But yeah, on a larger scale data, it will take much more time. So you can see the difference that with cache, it is far less. And then you can save the same embedding, like whatever embedding transformation pipeline we have. And then you can again load it by defining the transformations. And yeah, it took very less time because we have loaded from cache. Other than that, we can this is in-memory cache, but we can always use Redis cache. So we'll show it using the Quadrant client and Redis cache here. All you need to do is, yeah, you have to just define the Quadrant client and a vector store for it. And you can, yeah, we have all these transformations defined like earlier, but you define a cache which is ingestion cache with Redis cache, and give a collection name for that, and define the vector store as well. So here we are doing a quadrant vector store, so we have will be including that, and then you can run the same again. Yes, done. So you can actually check it here. Yeah, we have embeddings as well as yeah, there is text, and then should be the metadata as well, or else yeah, it should be, yes, this is here. So this is the meta, I mean the title extractor metadata, that's what I was speaking about. Yeah, that's how you can create use cache and load the already existing transformation, so that the processing time, node creation time takes very less. Yeah. And then we have the third one, which is custom transformations. So let's say we want to on the loaded data, you do a text splitter, have a text splitter, and then you want to clean the data. Probably you want to remove all the extra characters here. So all you can do is you can just define a custom transformation. The way here, text cleaner is one custom transformation. So it will just replace all the extra. It will remove all the special characters basically from the text. And all you have to do is include this transformation in the transformations in the ingestion pipeline. So we have text sentence splitter, then text cleaner, and then embedding. And you can just use the nodes embedding cache, because we have this already text splitter. So this transformation can be loaded with the earlier version, and then the other things are recalculated. So this can be even useful in cases, let's say you want to remove certain text. Let's say you have very personal data, and before creating embeddings or sending it to LLM, you just want to remove some personal data. You can just define your own transformation of clean. Like in text cleaner, you can create your own transformation and then remove all that personal data and send it to and create a pipeline. So this way the process becomes much simpler, right? So yeah, that is a third one, which is custom transformations, where you can create your own custom transformation and create a pipeline and create nodes. And then on top of this, you can create an index and start querying as well by defining creating query engine, right? And the fourth one, which is a new interface for node parsing and text splitting. So we have created an ingestion pipeline earlier with having a text splitter and then a metadata extractor. But you can use whatever transformations we have done earlier separately as well, like I am showing here. So we have defined a node parser or text splitter here, sentence splitter, and then we can have a metadata extractor. You can use all these modules independently. And so yeah, basically all these transformations independently. So apply a node parser here on the documents, and then a extractor on the nodes, now on the first transformation basically. So since title extraction is happening, and we can just check inspect the nodes. So yeah, so this compared to earlier, where you have to create a simple node parser from documents, abstraction, call it out, and then have a text splitter if you want to define a text splitter, and then again a metadata extractor. This makes the process simpler for creating new nodes by using defining the each transformations. And then, yeah, so till now we have seen ingestion pipeline, transformation, catching, and as well as custom transformations, and then using different transformations with a new interface for node parsing or text splitting or metadata extraction. And then the last one is tokenization and token counting. So for token counting, for LlamaIndex, we use GPT 3.5 as a default one. So we need to have the token counter set to be the LLM whatever we are using. So here we have a mechanism to set the tokenizer now. So you can have set global tokenizer. So here we have used a GPT 3.5 turbo tokenizer. And then if you want to use any other LLM, open source LLM, you can even set any other LLM tokenizer as well. For example, here I'm using Jaffer LLM from Hugging Face. So you can have that model tokenizer as well. And then in the usual process, you can fix the tokenizer and have a token counter and callback manager, define a callback manager, include them in the service context, and then create an index. And then since while creating an index, the node embeddings are used, First, we'll check what are the total embedding count, and then we'll reset it, because while querying, we don't want to measure the same the embedding counts during the creation process. So we want to reset them and then check beforehand going whether it is 0 or not. Run through it. Yeah, as you can see, we got the embedding count, we reset it, and then the new embedding count is 0. Now we will query the index, and then we can get the embedding tokens. We'll see what are the embedding, how much of embedding tokens used, what are the prompt tokens, and then how many completion tokens are used, and what is the total LM count basically. So as you can see, yeah, there are 8 embedding tokens, which is far less than like the embedding count while index creation, right? So because during querying, we only create embeddings for the given query, right? And then we have the next one, LLM prompt tokens, and then completion tokens, as well as the combination of prompt and completion tokens to give an LLM total LLM count, token count. So yeah, that's all for this video, and we have covered the important updates in LlamaIndex 0.9 version in this video. See you all in the next video. Thank you. Bye.